You are listening to Kubernetes Bytes, a podcast bringing you the latest from the world of cloud-native data management. My name is Ryan Wallner, and I'm joined by Bhavin Shah, coming to you from Boston, Massachusetts. We'll be sharing our thoughts on recent cloud-native news and talking to industry experts about their experiences and challenges managing the wealth of data in today's cloud-native ecosystem. Good morning, good afternoon, and good evening, wherever you are. We're coming to you from Boston, Massachusetts. Today is October 21st, 2024. Hope everyone is doing well and staying safe. Bhavin, what's new? How was your weekend, man?
Weekend was good. I forgot that we were back in summer
Yeah.
in New England this week.
Oh, that's right. It was really warm yesterday. Yeah.
Yeah, it was. It was like 72 degrees. So no, that was a good break from the cold weather that we have been starting to get in. So no, I had fun. Like spent a lot of outdoor time for sure over the
Good.
weekend. How about you?
Yeah, same. So Sunday, yesterday,
Mhm.
was my New England mountain bike chapters. The chapter I'm part of is Blackstone Valley, but it's our annual fundraiser ride.
Oh,
So this is
nice.
called the Best Dam Ride. We
Okay.
call it that because it's at West Hill Dam, which
Okay.
is
Yeah.
a Army Corps of Engineers property. Yeah, we had 400 people or something like that. I had a few hours of volunteering and then a little bit of riding, and
That's awesome.
yeah, it's a blast. So
So
we look
is it
forward to
like
it.
a run by a mile marathon like bike? Like how do you raise money?
Yeah, so you raise money just by selling tickets to the event, basically.
Oh,
And the
okay. Okay.
event
Gotcha.
itself, we do like a really great raffle. So,
Hmm.
as mountain bikers, we had things like a pull behind cart for like kids behind your back,
Yeah.
or
Yeah. Yeah.
a Kuat uh, bike rack for a car, or like
Okay.
new tires, new bike levers, all sorts of stuff, right? So you kind
Nice.
of like you get a free raffle ticket when you sign up, but the proceeds for signing up
Hmm.
go directly back to the chapter. And
Okay.
we have like food and ice cream and stuff there. And then, all the volunteers put on sort of events. Like they'll, go intermediate ride, a novice ride, advanced ride. We built the pump track this year. So we actually had 3 state representatives come and kind of, bless our new pump track,
Yeah.
which was kind of cool to hear them kind of give their speech on it.
Nice.
But yeah, it was fun. And yeah, the weather was killer. So can't complain.
Yeah. I'm like, do the state representatives like jump on a bike and go around the new
So
track, or they were older?
no, what's funny is none of them really did any mountain biking, but Specialized is a sponsor there, right? So they are
Mhm.
a vendor who comes there and they can demo bikes. So we got one of the reps to go
Okay.
on a Specialized mountain bike, and he
Nice.
has an e-bike and a gravel bike or something like that. And he was like, "Oh, now I'm gonna have to get a mountain bike," and he was doing the pump track and everything. So it was kind of cool.
Oh, that's awesome, man. Yeah.
Yeah.
A successful event for sure.
Yeah, it was fun. Can't complain.
Yeah.
But yeah, we have a fun episode today. We'll introduce our guests after some news, but why don't we dive into our news segment? Bhavin, why don't you kick us
Yeah.
off?
I can get started. OpenShift 4, the first item is OpenShift 4.17 is now generally available. So a few things that caught my eye. They support Kubernetes version 1.30. So Kubernetes, I still don't know how to say it
Kubernetes.
correctly. Yeah. But now if you're running OpenShift 4.17, you get Kubernetes 1.30. And if we specifically zoom into the OpenShift virtualization space, they added a few features like safe memory overcommit. So if you wanted to overcommit memory for your VMs that are
Nice.
running on OpenShift, you can do that. Memory hot plug. So if you want to increase your memory footprint for the virtual machines, that can be done on a non-disruptive scale-up basis. To improve your VM performance, they also have something called, this is something I haven't read in detail, but automatic VM workload balancing with descheduler. So to me, like just reading that, it sounds like the VMware DRS feature, where VMware
Mm.
basically distributed VMs across different hosts to avoid any hotspots in the cluster.
Right.
Maybe OpenShift is already doing that, so that's a feature I want to go and check out. And then another feature that applies to us is from a tech preview perspective, they added support for storage live migration. So you can
Sure.
take a VM that's provisioned on a specific storage class and live migrate it to a different storage class without. I think this is a feature that Red Hat themselves are working on without integrations with other storage vendors. I'm not sure. It wasn't clear in the live stream that they do, and we link the live stream in the show notes. But it shows that now you can, like, for an already deployed VM, change the storage backends
Got it.
using the console itself.
Yeah, that'll be interesting to know if it's going to work across like backend types of storage classes
Yeah,
too, right?
yeah, that's
Like,
my question too. Like, what if there are certain features that a specific storage vendor is providing and other is not, and how do you like, do you show a warning? Like, yeah,
mm,
again, it's a tech preview feature, so it's not, like, not GA, but
yeah, or if it
people.
works on top of a some sort of file system versus like a snapshot,
Oh,
and it really depends. I have to look in that too. I need to dig into that clearly.
yeah, no, I think this release definitely had a lot of features that need, like, more detailed evaluation of the documentation that they do. But I don't know, the live stream that the Red Hat product management team puts on is awesome. Like, man, they I don't know, they have created a great workflow where every PM from every different piece of OpenShift will jump in for like 2 minutes, hand it off to the next one. They know who's before you, who's after you, and they'll
Yeah,
come off video. And oh man, a well-oiled machine
good
for
vibe.
sure.
Yeah.
Yeah, I know. Okay, and then outside of Red Hat, okay, actually, since you're talking about OpenShift virtualization, something that I was down on my list, they have started publishing you customer case studies more publicly now. So they just put one on the new stack around how NVIDIA GeForce now uses or runs on KubeVirt. Again, this was a Red Hat sponsored post. I remember at Red Hat Summit, NVIDIA had a session maybe, but there was definitely a KubeCon session that will be linked from this new stack article, where they talk about how they run benchmarks or CI-driven benchmarks for their VM environments. But basically, it says that instead of modifying or modernizing their whole footprint from virtual machines to containers, they are like, instead, let's just modernize where they are running VM. So it's a cool little story, and the session is definitely worth checking out. So we'll link that to the show notes.
Cool. Yeah.
And then finally, for me, I think since we had an episode talking about OPA a while back, I've been following Styra, which is the company, I think one of the major contributors behind the OPA project. So they announced something called as Policy SBOM, and anything with SBOM, Ryan, we have to bring it
We have
to
to
for
talk about
sure.
S-Bomb.
Yeah, got to talk about it. So Policy SBOM is an inventory of policy modules, which includes their sources, versions, dependencies, everything that's within an OPA bundle. So basically, instead of just an SBOM, which is a bill of material for different components that are part of your application, Policy SBOM is an analysis or detailed description of what is included in a specific piece of policy. This is, I know, like, I want, the reason I brought it up was the policy SBOM integration, but this is, I think, only available to Styra enterprise customers. If you have their DAS subscription, you can now start using this. But this is an interesting approach that companies in this ecosystem are taking to document everything, and list out the permissions, the packages that are part of any entity inside Kubernetes. So just wanted to share that.
Nice. Gotcha. You mentioned Kubernetes, so I'm going to talk about a possible next release, which is 132, which is the one coming up.
Okay.
And we're going to talk about an article basically about the feature change block tracking
Hmm.
from the storage team. Basically, they're looking for feedback on CBT. So it was slated in Kubernetes 131 to be
Hmm.
alpha, but it slipped to 132. So now the APIs are going to be available in 132, and it's basically you're able to prototype with it and all that stuff going forward. And the storage team is specifically looking for feedback on change block tracking. So if you're
Okay.
not familiar with change block tracking, the TLDR is it enables you to do things like incremental backups. So
Yeah.
you look at an entire backup and see what's been changed, only report those blocks in some
Hmm.
metadata or something like that. And there you take a backup, which is incremental, meaning you're not
Yeah.
changing or backing up all the data. You're just kind of recording which blocks have changed, hence change block tracking.
Nice.
And and so this feature is going to be, I think it's been like 2 years in the works or something like that. I want to say the KEP, the 3314, said it was implementable in June 2024, as the article says, but it slipped. So I think this is a really cool thing. It's something that I think almost every storage provider does
Mhm.
provide. So having CSI sort of also enable it now is going to be an interesting space. So there's some great talks, I think, coming up in Salt Lake City if you're there. I
Okay.
believe. The data protection working group is putting on a deep dive talk. So if you're interested in this and you're going to be in Salt Lake City, definitely go check it out. Anyway, we'll post that
And,
article there for you as
and you
well.
said this is alpha feature for 132, not beta or
Yes,
GA, right?
yes,
Okay. Okay.
132. It'll be
Cool.
the alpha APIs will be
Got it. Thank
available.
you.
The other two things I had was Cube Edge is a CNCF graduated project now. So we've talked about Cube Edge before on the show,
Mhm.
but it's kind of fast tracked through its way through the process.
All right.
Not really fast tracked, but it's got a lot of support, for managing IoT devices and syncing data back and forth between the edge and so forth. So Cube Edge is making a lot of great projects. We'll post that article as well. And then if you use Pulumi, their 2.0 operator was also released, and it adds a whole bunch of things like scale and some other things. So that article will also be posted. And that's my
Okay.
news for today.
Man, Cubase, right? Like
Yeah,
going back to that for a second, like they have a lot of contribution from or support from different vendors in the
sure. Yeah,
ecosystem. Yeah, the graduation post has a lot of different
it's a
brands.
lot
One
of
that caught
names
my
in
eye was
there. Yeah.
ByteDance. It's like, how is ByteDance using Cubase? I don't know. It's a question that I need to figure out answer to. Is it running on our phones? Nope. If you have TikTok.
Just
No,
on your
no,
phone.
that's awesome.
Yeah, good stuff. So that's the news for today. We'll make sure all those links are in our show notes if you want to go back and read some more about them. But we have an awesome guest today. Here is the co-founder and CTO of Inferless. His name
Mhm.
is Nilesh Agarwal, and Inferless is really interesting stuff. And we'll let Nilesh comes on the show and kind of dive right into what he's doing. So without further ado, let's get him on the show. All right, welcome to Kubernetes Bytes, Nilesh. It's great to have you on the show. Give our audience a little bit of background of who you are and what you do.
Sure. So, hi folks, I'm Nilesh. I'm the co-founder and CTO at Inferless. Before this, I have 10 years of experience, mostly in machine learning and infra, where started with a US-based company where they used to do CI/CD, mostly for fintech banks like Deutsche Bank, First Data, some of their customers. Post that, have been in Amazon, where I was in the machine learning team, where anything that you see like an ad for Amazon product, we used to like ship all of those. We had like 50 million ads running across 16
Ooh.
countries at scale.
Wow.
Post that, I also started another dev tool company before this. And currently with Inferless, what we're trying to do is help companies deploy machine learning models faster, where they can like deploy it as a function and then we scale it up and down for them.
That's an impressive background, man. Just 10 years, you said. Okay.
Yeah.
No.
When people are putting out the advertisements for new jobs,
Yeah.
he checks that box of 10 years, even though there's not 10 years of like
Yeah.
the new technology. I always like when I see this.
You
Yeah,
need
that's
20 years of
machine
experience
learning.
in Kubernetes. Okay, so Nilesh, since you have so much experience in machine learning and inferencing specifically, right? That's what we are here to talk about today. Before we talk about Kubernetes or Inferless, let's talk about what the inferencing landscape looks like today. These models have been out and about for a while. How are customers or users deploying these? Are they doing DIY? Are they using just services from managed services from hyperscalers? Can you give us an overview of that ecosystem?
Yeah. So I think it's a very interesting one. I think the inference landscape is pretty broad, I would say. It's highly like in like three or four categories, right? And I think the first one of that is definitely the closed models, right? Where there are companies like Anthropic, OpenAI, right? Which have like, I would say 30 to 40% of the market share, right? Where they say that, hey, you just take APIs for us, we'll manage the underlying model, we'll manage the underlying infrastructure, and you just pay us like tokens per second, right? So I think
Hmm.
that is the first. I think the companies using that are mostly like people who need like raw intelligence. So you can consider it like for a company spectrum, like let's say they want just to analyze a mathematical problem or solve a case with just putting tokens in and out, right? So where there's
Hmm.
complex thinking, I think those are the like first kind of inferencing that's happening at scale now. The second, I would say, a still broad spectrum which is happening is like through these providers, like which is like second 20 to 30%, which I would say is with companies like Together AI, Azure, AWS, right, where they are
Hmm.
like just hosting models, and then these are OSS models, so these are not like proprietary models like Anthropic and OpenAI. So these are still like open source models, which are like, I would say, 80% as good as the like closed source models, right? Again, don't want to like be very specific on that, but they
Yep.
do the task. They are like you have a lot more control in terms of how your data flows, right? So this is comes to like, I think, mostly enterprises when you shift from like a commercial app to more enterprise B2B use case where data is sensitive, right? So the second biggest inference is happening in this. And then there is the third spectrum of company, which also Inferless caters to. Most of
Hmm.
them is people who are taking these Llama, Mistral, or open source models, but
Hmm.
then they have some of their proprietary data sets, and then they want to like, let's say, beat the category one models, right? So we have seen a lot of our customers, specifically like 10x and a couple of others, who have been able to beat GPT-4 or for performance, but only for certain specific tasks with
Okay.
a very low like cost, right? So that is where the third set of companies comes in, where we see a lot of inference happening. These are companies who have taken a task, they start from a task, and then they have like fine-tuned a model or a task to go deep
Right.
into that, right? So that is where we see the inference landscape, and these are the ones who are doing it more DIY,
Hmm.
going on Azure, AWS, getting the GPUs, or using providers, right? So there's a lot of mix
Gotcha.
within the third category.
So for the third bucket, you said it's targeted towards specific use cases, right? Like they want to beat the performance of these larger models for specific use cases. Who is fine tuning these models for that specific domain? Like are vendors like yours fine tuning models for like running a dentist office somewhere or a lawyer's office somewhere else, or these dentist offices somehow are creating an association and building fine tuning models that work for their use case and then working with you to host those? Like who owns the fine tuning?
Correct. So usually, like these are like probably like Gen AI focused startups, right? Who are like
Hmm.
building either a, let's say, a vertical chatbot in hospitality, legal tech, sales tech, right? Something like that. So we see a
Okay.
lot of these vertical players coming up who are picking a domain and then a task within that domain, right? Now, for them, how the pipeline goes is, first, I think they have to reach like a million users, right? With the open
Hmm.
model, right? So I think first is like a journey of finding PMF, right? Which I think is not a good idea to start fine tuning your model on day one, right?
Yep.
So that's the most companies we see being successful are the ones who like use Chat GPT or like the second part of the model, like Llama. So
Hmm.
people start with one of these two categories, and then they have, let's say, a product which works, right? But now, let's say once you fill in the 80% or 90% use cases, still you need to get to like very high accuracy. I think for each of the startups, the battle is
Okay.
towards the accuracy going towards 95%, and how can you do
Hmm.
better than like the
Gotcha.
in the last 10% use cases, right? Where typical general purpose AI would fail. That is where their moat also lies. So we see a lot of people like going beyond a certain threshold, and then they start investing a little bit like in like fine tuning, right? So at that point of time, they would have already served, I would say, over like 5 to 10 million queries, seen usage
Hmm.
performance across it, and
Okay.
they have data that, hey, these were the input outputs, and now there is two things: one is accuracy and one is cost, because both of these are pillars of how you want to give your service to the customer, right? These are the two efficient things that
Hmm.
come in. Yeah.
And one last question before we move on to actually Kubernetes or CNCF related projects. Uh, you said these are just fine-tuned models. Are vendors in the third bucket that you described also offering RAG or RIG? That's a new term that I learned, like retrieval augmented generation and retrieval interleaved generation. Are these vendors also offering those kinds of services where they can host the model, maybe have data available in a vector database somewhere, and without even fine tuning, you get to that higher percentage?
Yeah, RAG is a very interesting use case, right? Because RAG is, I would say, somewhere in the third and second both, and it's very interesting. Why is it both the categories? So yeah, we definitely have customers who use like a vector database along with a API from Inferless. So
Hmm.
usually this happens like, so when you are a RAG company, right, who's building like a prompt or something like that with a augmented generation or interleave generation, right?
Hmm.
You can either do two approaches, right? Either if you have a long tail model, right, which is not super famous. So let's say that could be like a Phi 3.5 or like some model which is very hard to find off the shelf. So then
Okay.
people come to serverless where they say that, hey, like I still want to do it, but this model is not readily available out of the box uh, in, let's
Mhm.
say, SageMaker or their like managed offering. So then they think about, okay, hosting itself. But for RAG applications where they're using, let's say, Llama 7TB
Hmm.
out of the box, right? For them, they often also tend towards the second bucket where they're like, hey, I just need tokens per second, right?
Okay.
I have a
Gotcha.
huge database. I need to encode this, send it into my database, take the API again, and then answer it for them, right? So the RAG is like spread across usually these two buckets, and then also the first bucket, right, where they some a lot of folks I know also use ChatGPT as the embedding model and directly use that for like RAG
Yeah.
based applications. So I think RAG goes up across the spectrum,
Okay.
and it really depends upon the like model and capabilities. Yeah.
Makes sense. So I know we're talking a little bit about the inferencing landscape, and since we're on the subject, and before we talk specifically about what you do at Inferless, what are the different sort of paths someone can take if they're interested in getting into this type of landscape, and maybe those are projects within CNCF. Which ones have you used, or which ones do you know of, or I'd love to hear your perspective on that.
Yeah. No, I think for model deployment, CNCF again historically has had a lot of projects, and especially like the one which I would like to highlight is the KServe,
Hmm.
because it's a fork of Knative, but which is very specific to machine learning, and which also is the need of the day. So I think that is KServe is one project that we look highly up to. Some
Hmm.
of the more advanced which are still in the incubation phase are like Nidus and like a couple of other like smaller projects, right? So these are the two projects that I have mostly looked at, and
Hmm.
like we have used them very heavily, and then like figured out what they do good and what basically are the areas which still like are not like fully there in these open sources.
Okay. Like, if since we are already on this topic, right? w- Since you have evaluated these different open source projects, what are some of the challenges when it comes to model serving or deployment using KServe, for example? Can you share some of those?
Yeah, sure. So I think just coming back to the like I think good things that KServe does first. So I think it's
Okay.
a great platform where I think it gives you a control plane where using your CI/CD you can just like put a quick YAML and then you
Hmm.
get like a ML service up, right? So it's super easy to set up. They have really good support for like backend servers like Triton. So Triton is one of the servers that NVIDIA has made it open
Hmm.
source. That's also an open source project by NVIDIA. That's a super good engine. It has like a lot of support for dynamic patching, streams, like streaming and all. So it's a pretty good one. And then KServe has been a good community that integrates with like ThoughtServe, it integrates with TensorFlow Serve and TFServe, and then also like Triton.
Okay.
So overall, like KServe is a great project, right? And then you can deploy a model like in any, let's say, Python, TensorFlow, PyTorch with using KServe, right? Now talking about some of the limitations of KServe, right? I think if you like see KServe was forked off a Knative, like which
Mhm.
was the original like open source
Hmm.
CNCF project, right? Now Knative was an excellent project for like smaller model and compute, right? And if you see the history of KServe, KServe is used in large organizations, even to some fact in Salesforce and like other ones which I know of, on a capacity of smaller models. So when model size is let's say 100 MB, 500 MB, which if you see before 2019, most of the models were in like that regression and prediction models in range of a gigabyte. It works really good because you can pull 1 GB model in like under 5 to 10 seconds, right? Or like a pretty slow machine also. But what it comes is now the landscape has changed, right? If you see with Llama, like 13B, 8B, like all of these models are in like 20 gigabytes plus, right? And some even go up to like 100 and
Hmm.
150 gigabytes, right? Now that is where like these systems are not purpose built for it, right? Because these are huge model weights. So orchestrating them in a way where, let's say, you're dynamically pulling the weights on request, right? That becomes a huge bottleneck, right? So if you have a K-serve cluster with, let's say, a 50, 60, 800 deployed, uh, like booting up a service will take like insane amount of time, right? And then that may lead to a bad quality of service for your end consumer.
Gotcha.
So that's the biggest thing where we see, and it's mostly because of the data size which has exploded. So that is
Mhm.
where the KServe and Knative platform are not very good. Second is all part of the container orchestration, right? Because they don't have a schedule, so their schedule is very generic, like it is based off the Kubernetes primitives, which is like this CPU, this RAM, this hardware,
Sure.
right? Find me this wherever it's possible, right? But I think that kind of scheduling also has a lot of downsides to it. Yeah. So these are the two things I would say mainly, like KServe and Knative are not able to, I think, catch up, or they'll probably catch up in a few years from now.
What type of scheduling decisions like are beneficial to these types of workloads if those basic ones that Kubernetes kind of comes with are not necessarily built with that in mind, obviously.
Correct. So what we have seen is the kind of scheduler that you need to have, right, for especially machine learning models, which are like 20 plus gigabytes. So one is like the container runtime, right, which is like your Docker file, right? How like PyTorch, which version, which packages, right? So there needs to be like some strategy which has like that is like Docker container image is also a first class resource where you say like 20 GB of RAM, where you can also say that hey, I want this Python version and this CUDA version to be there in
Mm,
like some node, right? So that's one. Second is of course the model weights, right? So there needs to be some way in, let's say, sharding or some combination of scheduling where we say ahead of time that hey, let's say I for a typical very big company, right, like Salesforce or some example, right?
Yeah.
We have like 100 models, and each of these models have, let's say, some traffic pattern which we can like see. So based on that, can we do some prefetching or pre-caching to make the uh, like model weights there in some way, or maybe we have a distributed storage that's fast enough to like pull
sure.
this model like on the fly, right? So those are two different approaches, but I would
Mhm.
say these are the things which I think the scheduler should also consider. Model as a first class resource and then containers as a first class resource, where that would solve the problem of like making it like super fast for the LLMs or diffusion models of the current era.
Okay. So is the challenge more on the startup time? Like it's a startup issue, right? Similar to I think when Ryan and I were doing our serverless episode, the cold start
Hmm.
problem was a big one where
Yeah.
whenever the app needed some resources, a Lambda function needed to be spun up to serve that traffic. This is more around day zero, but once you have deployed things using Kserve,
Yeah.
actually running it on Kubernetes is not a very big challenge.
Yeah. So I think it's definitely the scale problem. So it's not just 0 to 1, but also 1 to n problem. So that way it's pretty linear, right? Let's say
Mhm.
there's an app called Photo Room, right? And we talk, in our early days of Inferless inception, we talked to them, right? So they say that they usually have to provision like 2x of their like infra. So let's say at a point, if they use like 10 GPUs, just for example, right? So they have to provision 20 because their time to like let's say once the customer starts using them, right, for them the denial of service is something that their business cannot deal with. So if
Mm,
a flux of users come in, so they have to make sure that they are able to rapidly scale up, right? So scaling is basically like slower because of the like underlying details of the model and the container and the runtime and everything, right? So that is where
Okay.
this problem still persists even at scale, right? So it's like how do you start a pod faster?
Yeah, yeah, yeah. Okay. No, I think that makes sense. If I have an auto scaling rule in place, model at the end of the day is running as a container or a pod on
Yeah,
your cluster.
yeah,
If you
yeah.
get more requests, then how do you? Okay, okay. Thank you for clarifying that because it for me it initially sounded like a 0 to 1 problem. So
Yeah,
no,
yeah,
this
no, it
helps.
is. So yeah, 0 to 1 is for sure. Like if let's say companies have an array of 1,000 models and they have 100 GPUs, right? They want to figure out a bin pack so they can quickly load and unload. So sometimes it's 0 to 1, but then the
Mhm.
same logic also goes from like 1 to n in
Yeah.
solving the same problems. Yeah.
Cool. Well, I think it's time to maybe switch gears a little bit off of the CNCF projects and talk what you're up to specifically at Inferless. I'm interested in sort of why Inferless is here today. Why did you decide to kind of like go about building this company and sort of talk about the origin story a little bit, and then we can dive into maybe what you're doing specifically to fix some of these challenges.
Got it, sure. So I think again, Inferless is like a pivot from the original company that we were building before this. So we were trying to build an AI coaching bot which could help
Mm,
people with their behavioral skills. And this was back in 2019-20, where GPT-3 was not like publicly launched, but like it was available out in beta. And we had some open source versions of that also, like GPT-J, GPT-Neo, right? At that time, OpenAI used to open source most of their models, right? So while experimenting with that, what we figured out was that we were trying to host these models on Kubernetes, right? And we were
Mhm.
using some of the said open sources. But then we figured out that we had to like keep a lot of GPUs on and like really
Mm.
over provision. So let's say at a month we were spending like $20,000. So we were doing like $2,000 in revenue for like the customer for serving those, right? So
Mhm.
that was the origin story of it, where we saw that hey, there was no way in AWS Lambda or even Google Cloud Run to like give them a model and then say that hey, when I call this model, turn it on and just give
Mhm.
me the output of it, right, whenever we require. And then similarly, like so that was our problem. But then we also talked to a lot of folks, probably like 60, 70 plus engineers who were at that time in generative AI trying to build early diffusion based models. So most of them, it was the same story where their cost of like infrastructure was even like greater than the cost of what they were earning from the users, right? And while that is okay in the early part, but I think there's some at some point the scaling laws have to match, right? Or else you can't build a sustainable company, right? And then we also landed up to double tap on this theory, also landed up on a report which was by A16Z, that they are saying that the gross margins of AI companies are actually as good as like a service based company with humans, right? Because
Yep.
they have to invest on training, they have to invest in continuous inference, and those are not like SaaS. SaaS was like 5 or 10% what you would probably spend in infra, right? But here it's
Mhm.
like 40%, right? So that validated our theory, and that is where we started that hey, there should be a way to do it serverless. Then the next couple of months on Inferless was us that hey, can we really solve that problem? So we gave us 6 to 9 months in just saying that hey, how can we run this model faster? Let's say if what's an acceptable limit? Let's say it starts in 5 seconds, it starts in 10 seconds. Are customers okay with that penalty, and can we build something around that penalty, right?
Mhm.
Of scaling the pod. So that is when we started. So the first version of the product which we wanted to build was like something that's like managed, completely managed for like the end customer, where we go back and like rent out GPUs from Azure and AWS, but then make sure that when they want to scale up their pod or service, it gets done in like under 10 seconds, right? So that's the
Mm.
benchmark we set for ourselves, and we launched earlier this year, and then since then we have now been working with 20 plus companies. We're still in private beta because there's still like a lot of scaling mechanics that we are figuring it out. But that was the origin of like how we made it serverless, right? And so these are like you can come up with any model and any like runtime, let's say PyTorch, TensorFlow, whatever, and then we just help you like get that service up and down like super fast, and then you can also scale with us like 0 to 50 or 100 GPUs and then scale back.
Gotcha, gotcha. Now, I do have a follow up question just because Bob and I have had almost an entire episode on this one term, right?
Yeah.
Serverless. So I do want to clarify from your words, what makes Inferless serverless in your own words, and maybe explain a little bit of the difference between going on some of your documentation around deploying serverless containers versus ML models directly with Inferless.
Got it. Yeah, so I think the term serverless from an end customer, right, means that they don't have to manage the Kubernetes or the plane of the data plane, right? So that is where the like pure definition of serverless is, right? Because I think serverless is a word where which has been like, is there an open source serverless? And then there is like a lot of variations of I think the word
Yep.
serverless. So I think in
Hmm.
the purest fashion, what serverless means is basically like for the end user, they don't
Hmm.
have to worry about where the compute comes from, and like they just have a piece of code which gets executed like on a remote machine, right? And
Right.
that machine like is needs to be out of the customer's data plane, right? So there are a
Hmm.
lot of like managed serverless also, but I would say that they solve the same purpose, but I would say by definition they are not serverless, because if you have to manage server. So our definition of serverless is like for customers they don't have to manage OS patching or anything regarding the resource, right? The resource is completely managed by us. That's why we call
Gotcha.
it serverless. Coming on to the second question, like serverless containers versus ML models, right? So I think uh, when we set like machine learning models, right, that makes the scope a little bit limited, right?
Hmm.
So uh, this was again something that we discovered on our way, right? So uh, machine learning models typically like the PyTorch or the TensorFlow like file which you have like with weights, like Safe Tensor or something like that, right?
Mhm.
So when you talk about serverless containers, they can also have like a pre-processing logic in Python or like some runtime that basically allows them to also like run multiple forward iterations, right? So
Mhm. Mhm.
that's why we made it serverless containers, because these are just not machine learning models, but wrapped with, let's say, the necessary logic. Let's say it processes it,
Tools
stores
and
it to
logic.
S3, something like that, right? So that's the really difference that there are a lot of, I would say AWS also in some fashion allows serverless containers, but serverless containers with GPUs is something that's like none of the cloud providers today give access to. Yeah.
Okay.
So that's what we are about.
Got it.
Interesting. So I think I want to skip a couple of steps, and I want to assume that okay, customers have figured out how to run these models either using Inferless or on their own on Kubernetes cluster using KServe. One perspective that we are that I don't know the answer to is how are organizations that are at that stage updating their models. So I know open source like companies that are dedicated to publishing open source models have new releases every 4 months, every 5 months, where they increase the performance. uh, how are these models being updated in production? My assumption right now is I'm updating my app using either GitOps workflows where code commits already make it directly to production, or I'm running some sort of a canary or a blue green deployment where I'm testing two different versions of the application. Now with models involved, and they can impact the features that my application has or the output that my application has. How are organizations handling all of those updates?
Got it. So again, I can talk from an experience of few people. So I think this was a very interesting part, and
Hmm.
something that we also like learned along the way on our journey of 6 months. So
Hmm.
initially we thought that people would come, they would deploy the model once, and then they would just go away and come back after 3 months. But what we were surprised with our learning is that they were like changing the model every week, where either they
Okay.
were tweaking the
Okay.
parameters or they were tweaking the uh, like temperature or like some setting or the other, right, which could change
Hmm.
dramatically how the inference is happening, right? So when it comes to inference, uh, I think the permutation and combinations of different types of libraries, let's say VLLM,
Hmm.
TensorRT, like even if you have the same model weights, the library that you are using for inference can cause a huge change in how the outputs are
Sure.
producing, right? So
Yep.
that is one learning, and that is, I think, the most important flow which people regress, like thoroughly test on us, right?
Hmm.
And we had few customers who were using serverless just to test our models, right?
Mm.
Because one of the things which it comes with GitOps is like, so definitely there is a way of like pushing the model to production, right?
Yep.
But I think instead of a blue green deployment or like canary kind of thing,
Hmm.
what we see most of our customers doing at least is like they have a very good set of evals. So they use
Hmm.
evals mostly, and they have, let's say, a huge data set of evals, and then they would have like a dev endpoint, which they would deploy the new model. They would run
Hmm.
the evals on it, and then they would deploy it on the like with a production customer, right? So that
Okay.
is how like we see most of the like models getting rolled out in production. So it's definitely like blue green, but like part of traffic on one model and part of traffic on another model is like something that we have not seen. They
Okay.
usually use like evals to go through stuff like that, right?
Okay.
And the beauty of serverless there is like, again, I think especially for testing, is that you don't have to like set up a huge cluster, turn it on, and then uh, like keep the machines there, or like some like in a dev environment it's very hard to manage the infra, right? So
Yep.
serverless as a solution, a lot of people use it just for that. So there are a couple of customers who are just like putting their test workloads on us, doing the evals, and then they do it in the most cost efficient manner, right? Because they don't need to keep the GPU or provision machines for that, right? So
Okay.
that's a very interesting use case that we see with
Mhm.
GitOps. Like, let's say for people changing their model, right? To answer your
Mhm.
original question, I think what people do is we have like a lot of integration with CI/CD, so you can integrate with us on a code commit level, on a GitHub webhook level. So you can set up, let's say, a webhook that hey, whenever I push the code to this branch, it automatically gets built. So CI/CD is the next 3 months of our journey, which we had to build for
Okay.
developers to efficiently use Inferless.
Okay. Is there a term for it? Like I know when when we started using things like Ansible and Puppet, initially the community coined the term infrastructure as code. I know it's still going strong. Uh, like your infrastructure is code, your code is code. Now your models are also code. Do you have a new acronym for us?
Models
Not
themselves
that I have
code.
discovered. Yes.
Okay, no, thank you for walking us through. I think I'm interested. So, how are they managing these different versions? Is it in their source control repository and that's it? Like they are treating the customers are treating that as their single source of truth in terms of what models are being run in production?
So yeah, usually what happens is they deploy like, let's say for like one of our customers, they have like a three endpoints when we'll be staging dev and like prod. Prod is the one which is exposed to the customer. They push their model to staging once, which is like a GitHub branch. So basically, this is the like for one of the customers, it's like a GitHub based deployment. And then with GitHub, they have three branches, right? So first they would like commit to a branch, and based on that branch, the endpoint with Inferless would get upgraded. So let's say if we have like one endpoint configured on a staging branch, so as they
Yeah.
push their code to staging, then there are like a eval test, and then the same code is just promoted to like prod, and then like the prod endpoint is switched to the newer model.
Okay.
Got it. All right. Well, we're gonna switch gears on a little bit of a case study. I know this is something Bob and I always like asking our guests, and especially if they can talk about one of the real world examples or customers. So, we saw a case study on CleanLab that kind of talked about saving a whole ton of GPU cost.
Yeah.
I'd love to hear more about sort of how that came about and how they were able to do that with you.
Got it. So yeah, I think CleanLab again, just to give everyone a brief history, is like a company that helps like companies to clean their data based on LLMs, and some of their
Hmm.
customers are bigger companies like Amazon, Google. So one of the things that they do is like so when they clean a data set or something, right? They have like a lot of hallucinations. So sometimes your model can
Sure.
hallucinate and let's say write a data point which is just not coherent with the whole scheme of things, right? So there was this one particular tool. So hallucination is something that's like detecting hallucination is even harder than answering like an LLM question, right?
Hmm.
So the compute needed for that is, let's say, if you want to detect a hallucination, you will pass it to like three or four models, try to see which works, which doesn't work, right? And can
Mhm.
I flag this as a hallucination rather than a right prompt answer, right? So for them, they have like a public tool for detecting hallucinations also. So this is a tool that they directly have it open on the web, so they have no
Okay.
control on how the traffic flows for them, and it's pretty erratic. So the traffic erratic part was something that triggered them that, hey, like I have launched this in public, I don't know where most of the people will use it. It could be like 2 a.m., could be 5 a.m. There's no predictable traffic pattern. So for them it mattered that, let's say, whenever there's a burst of traffic comes in, so if hallucination is not detected in like 5 to 10 seconds, then like everything after that pipeline has ran, right? So it's kind of denial of service, like if it exceeds a certain threshold of seconds. So it had a constraint on that, and that's when they discovered us, since we were able to like auto scale their pods in 10 seconds, and I think the hallucination detection part takes like another 1 or 2 seconds for them.
Hmm.
So it was like if they could still like scale from 0 to 30 GPUs and like detect all of those hallucinations together and then like shut it down whenever it's not using. So that is where they used us. So they used our endpoints to deploy like a model with us for hallucination detection.
Got it.
It does the hallucination detection and then basically gives them a binary answer that, hey, is this model hallucinating or not? And for that they have like bursts of traffic, right? So at a point we would see them using like 2 or 3 GPUs, but in
Hmm.
the next instant they would go to like 50 or 60 odd like replicas trying to detect hallucination, and then it would go down to Z3, right? So now the other way for them was they could have also deployed it on a Kubernetes. So I'm not going to name it where they were going to deploy.
Sure.
But
Come on,
yeah,
man.
I think that's confidential. They
Yeah.
have asked me to keep it
No,
that way.
that's totally fair.
Yeah. So what they were deploying is, so for them to achieve the same output, they were like keeping on 25 GPUs, right? So
Sure.
even if it takes like when the scale is 50, so even it takes like a little bit more time, it's fine with them. But they had to keep 20 or 25 GPUs always on, right? Because if they keep
Hmm.
three GPUs on, the time it will get to like
Yeah.
answer like 25 GPUs, it will be too late for them. Their customer will have a denial of like service, right? So that was the use case where it was a latency sensitive use case. And since we were able to scale in 10 seconds, that was a key factor for us to do it. And then we saw that their average usage is like 3 or 4 GPUs, and then it goes to like 30, 40, like during some point of the day and goes down.
Yeah.
So they were significantly able to like save those over provisioned GPUs, right? Which was like 20, 25 GPUs, which was like
Yeah.
the bulk. If you see like 3 versus 25, it's like 90%, right? So
Yeah.
that was most of the use case for them.
Gotcha. I'm assuming there is like an AI model that can help you chart some of these usage statistics and scale
Yeah.
under the covers. Sorry. Okay. I think we are almost at the end of our list of questions, right? I think one thing I wanted to. This is still an early space. Like I know, being in Bay Area, uh, things can move so fast, and especially with AI, like everybody's talking about it as if this has been around for the past 10 years.
Yeah.
uh, since you guys are in it day in and day out, I wanted to ask you for any best practices that other people can use when they're trying to deploy these models in production, or any lessons learned that you want to share with our listeners, that oh, make sure you keep an eye out for this, so they know how to proceed down this route.
Yeah. No, I think definitely I can share, like, again, I think some of the ones I already shared
Mhm.
organically, that don't try to fine tune your model until you have like a few customers.
Yep.
That's always a bad idea. So I think for people trying to run their models in like production, trying to offer any kind of a AI service which involves like significant inference, I think it's a very like kind of a decision chart, right? That when do you want to take the cost of ownership under you, right?
Hmm.
Because with AI, things can get super costly, super fast, right? So
Hmm.
you would want to avoid the cost of ownership as long as you can, right? So that is what I would say, especially for early companies, right? Because there are too many parameters of control here, right? So the best one is to like start with probably one or two, where I would say start with OpenAI or like
Hmm.
some hosted provider where you basically get your first couple of users, print the MVP with RAG, prompt
Yeah.
engineering, or whatsoever. Once you have a significant that, hey, I've solved this business use case, now I need to get to the efficiency, right? Or like accuracy. So efficiency and accuracy is something that people should now think that, hey, now let me start owning the infrastructure, right? Where I want to
Hmm.
control parameters which are not in my control in these most of the providers, right? And from there, you basically say that, hey, till when should I deploy a model myself versus, let's say, I should take something like Inferless, right? So there we say that if you see like your utilization is less than
Hmm.
50%, right? Then that's a good trigger point for you that, hey, if I'm not using the GPU all the time, then is it a good idea for me to own this GPU, right?
Gotcha.
For the whole set of time. So that's when we say that that's a second branch decision that you take everything in cluster, or like just go with a managed service which just gets the GPU and gets your job done. And then also it also boils down to a traffic decision. Sometimes even it's like if your traffic is too spiky and you are a very small team, even if you are paying like 10-20% more, it still makes sense not to hire people to do this. Because with ML ops, there are very few people who have really good experience in how to like drive the best efficiencies with it, right? So
Yeah.
that's a very cumbersome process. And I think I think whoever wants to, let's say, takes a decision that, hey, I want to take control of like the GPU, the Kubernetes, the infrastructure. I think Knative is definitely a good way for them to look at whatever how they can like manage different API services. Uh, yeah, so that's
Okay.
how I
No,
would say.
thank you for that. Those are actionable things that people can start thinking about, like right now.
Yeah, absolutely. That's great. Speaking of where people can take some action, where can people go to learn more about Inferless?
Yep. So I think in terms of Inferless, we do blogs on our like website only, where we talk about like, let's say, Triton, how to deploy models on that, how to use Hugging Face. We also have a GitHub, like open GitHub repository. So what we do is we try to optimize the tokens per second, and then also
Mhm.
like publish that, hey, this is the like configuration that you can deploy to get the most tokens per second. We have benchmarked this across this hardware. So that is something
Mhm.
that we also publish as resource quite often. And then I do also have a Medium blog where I share like my learnings of the Kubernetes scheduler, how we can like probably contribute to that. Yeah.
Perfect. Is there any way? people can kind of get in contact with you yourself, or on any social or LinkedIn or anything like that?
Yeah. So definitely, I have like my LinkedIn and Twitter. I think I'm pretty active on both of those. So if you have any questions
Awesome.
specific to the deployment,
Hmm.
if you're trying to configure something in your class in your own VPC and want to like ask about like what are the challenges you're probably gonna run into, happy to help.
Cool. Well, Nilesh, it's been really awesome to talk about this topic. I think this is a perfect example, Bhavin, of in some time we have to have you back on the show, Nilesh, and just kind
Yes.
of see where you've come, and this is such an evolving space. I'd be so curious to see your success, hopefully in the next year or so. But yeah, we'll get you back on the show eventually, and thank you for joining. I appreciate it.
Thanks. Have a good one.
All right, Bhavin, it was great to have
Sorry,
Nilesh.
what? Is this the same Zencaster link, and how will it affect? Like, does
It's
it
just
show
two
up as
different.
different?
When you're on as the admin, you see
Oh, you can
recording
see
one and
different.
recording
Okay.
two. So this
Okay.
is just
Cool.
you'll just
I
see
was
two.
worried that the other session shouldn't go away.
No, it
Okay.
just says two. So you'll like jump
Okay.
into
Okay.
recording one to download it, and then
Okay.
recording two to download this one. Yeah,
Cool. Sorry for interrupting your flow.
fine. All right, starting over. All right, Bhavin, it was great to have Nilesh on the show. I know I was kind of excited about this one because, I reached out to Nilesh and was sort of interested in kind of what they were up to. I know during the talk, and he kind of mentioned that it's kind of only 6 months old, so really early
Yeah.
days for Inferless, and just in general the AI landscape. So really interesting stuff from today's show. But what were your takeaways? I'm curious.
No, I think I like that he's in this ecosystem, right, and building a company, so he gets to talk to customers day in day out. I like where the way he laid out the ecosystem overall, like the three different buckets: the open AIs and the
Mhm.
Anthropics that have their own service, the hyperscalers, and then vendors like Inferless. I think I like that breakdown. But and I think challenges, right? It was helpful that he walked us through the 0 to 1 and 1 to 100 problem. Like deploying a model is not enough.
Right.
Models have to keep up with the traffic that you are expecting, and once you have any AI based application, even a dumb, I don't know, poem generation, name generation, you will get so many people to just experiment with it.
Hmm.
So I think your backend infrastructure has to keep up. So some of those challenges that he described were good. And then from a best practices perspective, I like the way he wrapped things up by saying, like, first of all, think about cost, right? Like
Yeah.
that is one of the biggest lessons learned. You don't want to invest millions of dollars in buying Nvidia GPUs and running it on prem in your own data center. You first need to identify that use case. Second, don't start fine tuning immediately. See if you can reach a certain performance level and get early customers to use your application that is AI enabled. So I think all of those perspectives that we got from him were super helpful for me.
Yeah, absolutely. And to that point, right, he was saying, a lot of these models, whether, the example of what was the name of that company? CleanLab, which is like
Hmm.
deploying a number of different models to detect hallucinations, or
Yep.
I think you mentioned that it's quite often that they're deploying three of these for like staging and those kind of
Yep.
things. You're gonna deploy, you're gonna scale really quick, right?
Yes.
And that kind of brings me to the point at which we were talking about KServe and some of these other CNCF projects. I think it just speaks to the fact that Nilesh has kind of worked with these tools and says they're great tools, but the
Yeah.
maturity at scale, or when you're kind of thinking about the details that he talks about, model weights and where those models are being served from, and
Hmm.
how quick the startup times are, that some of the scheduling aspects weren't really as mature as they need to be to, I don't know, run a company or build a company
Yeah.
on.
Yeah. Yeah.
Not to say that they're not super useful, if you want to dedicate developers to giving back to that project, or
Yep.
even enough developers that or people familiar with this that really kind of can spend the time day in and
Hmm.
day out, because it sounds like the end user is going to tweak a lot of things, and you're going to be supporting the project that allows them to tweak a lot of things or redeploy it, right? So as with anything, you have to balance that complexity versus using sort of an as a service, right? And there are times, just like we say, there's a time to use Kubernetes and there's time to not use Kubernetes, right? We've said that so many
Never.
times on this show. I think this is similar, right? There's a
Yeah.
time to manage your all your own AI infrastructure, and there's a time to kind of outsourced to SaaS. So yeah, I thought that was an interesting aspect, especially early days, to kind of be, and I think this just kind of points back to, do you want to move fast, and how fast do you want to move, and what are you going to do with it at the end of the day? So
No, I think that's a perfect way to sum up the episode.
cool. Well, I think that's all we had. We'll make sure and post all the links that Nilesh had to offer at the end if you want to get in contact with him or check out Inferless or some of these other projects that we talked about. But yeah, I think that brings us to the end of today's episode. I'm Ryan.
I'm Bhavin.
And thanks for joining another episode of Kubernetes Bytes. Thank you for listening to the Kubernetes Bytes podcast.